Good afternoon. I want to thank the organizers for providing me with the opportunity to make this presentation remotely. I regret not being able to be there to see everyone in person. Unfortunately, we host a conference every 3 years, an end of research cycle conference here at the NCAP Pavement Test Track, and it's this week, so it was not possible for me to be there in person. But I certainly appreciate the opportunity to make this presentation in the Innovation in Road Technologies session. The title of my presentation is National Study to Quantify the Benefits of Pavement Preservation. And I'm an assistant director at the National Center for Asphalt Technology at Auburn University. Just for kind of a point of reference, we're engaged in a partnership with the Minnesota Road Research Project, and that thus the national impact of the research that we're doing here in pavement preservation to quantify the life extending and the condition improving benefits. So as I go through my presentation, I've organized it to start out with a little bit of background information on how the research came about and the nature of our partnership with the Minnesota Road Research Project. Give you an overview of the treatments and the treatment combinations that are included in the research. Brief discussion of the performance measures that we're collecting on a regular basis. Go through the benefits and the practical findings that we've determined and quantified at this juncture in the research project, and then finally provide you with a little bit of an overview. And I'm going to go very quickly because I know this is a 20-minute presentation. So as I said, I'm the assistant director at the National Center for Asphalt Technology here at Auburn University. The test track is a 1.7 mile oval located about 30 minutes from the campus at Auburn University. Our effort here at the National Center for Asphalt Technology is with flexible pavements. So all the research that we've done in terms of improving mix performance, optimizing structural pavement design, and then quantifying the benefits of pavement preservation, it's all with a flexible pavement performance. We rebuild the track every 3 years and reset the experiment, and we are a research cooperative, so we sell test sections primarily to state agencies, state DOTs, but also to the United States federal government and to private sector partners that are cooperating with the state DOTs. And then once we build test sections, we have a fleet of heavy triple trailer trains that we use to compress 10 million equivalent single axle loadings into about 24 months of fleet operations. So we are just now finishing research in our 6th research cycle, and we'll be rebuilding the test track this summer for our 7th research cycle. Well, beginning around 2011, 2010, 2011, noting that we do research in order to meet the needs of our state DOT clients. We're hearing from our state agency clients that they really needed a better way to quantify the life extending and condition improving benefits of pavement preservation, so they could do life cycle cost comparisons to drive their treatment selection process. So we began working with the pavement preservation industry, working through FP2, the organization formerly known as the Foundation for Pavement Preservation, to refine an experiment design that we could use for this purpose. So with FP2's help and with the industry's help, beginning in 2012, we started building test sections off the track, starting with low traffic pavement preservation on a county road that's a dead-end access road to a quarry and an asphalt plant. This was Lee Road 159, and this was done in the summer of 2012. So this half-a-mile roadway, the 23 treated test sections on Lee Road 159 have now been down. This summer will be 6 years. Well, that was a low traffic preservation at our southern United States location. And in the summer of 2015, we built high traffic pavement preservation test sections over on US 280, located about 5 miles from the test track. So we took what we had learned on Lee Road 159 and we expanded the experiment onto our high traffic test sections over on US 280. Also in the 2015 research cycle, noting that we went from low traffic to high traffic down south. That's when we engaged in our partnership with the Minnesota Road Research Project, and we have duplicated this effort up in Minnesota as part of a two-part national priorities partnership. This half of the partnership being in pavement preservation, and the other half being in mixed performance testing. So now we've got accelerated traffic preservation sections that we've done on the track. We've got low traffic and high traffic down south, and we've got low traffic and high traffic up north. And we anticipate a long-term data collection relationship with the Minnesota Road Research Project. So the treatments that were included in the research were driven by the work that we did with FP2 to design the experiment, and then we refined that with feedback from our state DOT clients. On the emulsion side, we have different types of fog seals. We have chip seals with and without rejuvenators and fibers, and of course with rejuvenators, that's with a broom trailer as a scrub. We have microsurface with and without highly polymer modified asphalt fibers, and then in a double layer application. And then we have cape seals with quotation marks, because I know that a true cape seal is with a slurry, but we have microsurface on chips and scrubs, and the chip seals with and without fibers. So a lot of different standalone treatments and treatment combinations on the emulsion side. And then on the plant mix side, the thin lay side of our preservation research, we have 4.75 nominal maximum aggregate size dense graded asphalt thin lays. We have virgin mixes, 50% wrap mixes, fine fractionated wrap, 5% shingle mixes, and then finally we have 11% fine fractionated wrap and 3% shingle, the 475 dense graded thin lays. We have dense graded thin lays on 100% wrap cold recycle, and that's with central plant and in-place cold recycling. And then we have what one of our DOT clients, research sponsors, calls HMA cape seals. We have thin lays on top of chip seals and scrub seals. And finally, we've got OGFC surfaces, open grade friction core surfaces, that we've placed using different types of tack materials. So there's a broad array of treatments and treatment combinations that we've included in this experiment. It's intended to be comprehensive on the flexible pavement side, again, designed and executed with oversight and decision-making authority from our sponsor oversight group, in which FP2 is an equal funding partner with all of our state DOT clients. So with these sections in place now since 2012 and 2015, 2016, we're measuring performance on a regular basis. We have weekly, monthly, and quarterly inspections and specific performance measures that we do at different points in time. Of course, we're measuring friction, macro texture, subgrade moisture contents, an array of performance measures that are being done on a regular basis. But the core of the experiment from the state agency perspective is our United States federally mandated performance measure metrics, and these are the MAP 21 performance measures. So that at the core of the experiment is cracking as a percentage of the total lane area, rutting, and then roughness in terms of International Roughness Index. So what I'm going to focus on in this presentation is cracking, because we have noted in all the test sites that rutting and roughness are relatively constant over the long term. So there's not been a lot of change. Essentially, the rutting that was in place when we built the sections is the rutting that we have now, and the roughness that was in place when we built the sections is the roughness that we have now. What we have noted changing is a percentage of the total lane area cracked. So that's what I'm gonna focus on, and I don't have a lot of time, and I'm going to share some data with you to show you how the experiment is developing. So we're on a weekly basis, we're inspecting our test sections, and we're quantifying how much cracking we're measuring in these sections and relating that back to the pre-treatment levels of distresses. What were the conditions of these roadways in, these test sections in, prior to the installation of the treatments. That's kind of the core of the experiment, is to relate the varying levels of performance that we're seeing from our treatments and our treatment combinations back to varying levels of pretreatment condition. So what you're seeing on this slide is real data that we've collected for our triple chip seals on Lee Road 159, and then in green, the green line is the percent of the total lane area cracked, solid green, for the portion of the test section that was in pretreatment good condition as defined by the MAP 21 performance measures. What you see in yellow was in pretreatment fair condition, and then in red is pretreatment poor condition. What you see in the dashed lines, that's what's happening in the control section. We're using data from the control section to estimate the cracking that we would otherwise be observing in all of our treated test sections. So looking at the fair condition, the MAP 21 fair line, the shift in the x-axis is the life extending benefit. So we're continuing to collect data on Lee Road 159 because for this combination of treatments, the triple chip seal, we've not yet defined. We have the solid yellow line has not yet come down to the starting point for the dash yellow line. So we've not yet defined the life extending benefit. But what you can do with this data on an ongoing basis, if you're an agency and you're dealing with the MAP 21 performance measures and you're under pressure to maintain your network at a certain level of condition, at year 5, the y-axis shift is the condition improving benefit for that portion of this test section that was in fair condition prior to the installation of the treatment. So the objective of the experiment for the good, the fair, and the poor is to determine the x and the y-axis offsets, which is relating performance of the treatments back to pretreatment condition. The two things that really drive the performance of treatments is design and construction quality, number one, and then number two, just as possibly more importantly, is the pretreatment condition of the roadway. So what we're doing is we had really good designs, we had really good construction practices, good inspection practices. So we're relating performance of these treatments back to different levels of pretreatment condition. That's really the innovative thing that we're doing with the experiment, and we're viewing that through the lens of the MAP 21 performance measures. So this is a view of Lee Road 159 to provide you with an update of where we are with the experiment. The inbound lane, this is a dead-end access road to a quarry and an asphalt plant. So the inbound lane trucks are running empty as they drive into this road. In the 6 years since these sections have been placed, we've applied 70,000 easels to the inbound lane and 860,000 easels to the outbound lane. And that is of the time that I'm making this presentation to y'all in this conference. If you go to the US 280, which is our high traffic southern test sections, our test road is 4.5 miles out on US 280, very near the NCAP pavement test track. These sections were placed in the summer of 2015, so over 3 years this summer. They've seen 5.4 million vehicles just in the eastbound or the westbound truck lane, and that equates to just over 1.5 million easels just on our preservation treatment. So we've got really an expanded set of treatments on 280 based on the successes and the failures that we've seen so far over on Lee Road 159. So we tried to expand the experiment in a very targeted way and take full advantage of the full length that we had available to us over on US 280. So far, all the treatments have performed really well on 159 and 280. What we're doing is we're tracking the return of the stresses, roughness, rutting, and cracking, and then we're comparing that back to the untreated condition in order to quantify the life extending and condition improving benefits. That's great for the southern half of the United States, but for the benefit of the northern states, in order to really optimize the nationwide impact of our findings, we have engaged in this partnership with the Minnesota Road Research Project, which is part of the research arm of Minnesota DOT in the extreme northern United States. This is an aerial or satellite view of the Minroad dog bone low volume loop that you see, that loop there on the northern side of the interstate. And then there's an interstate bypass lane that we have mixed performance test sections that we've built in support of the other half of the partnership that we have with Minnesota. We have select preservation sections that we've built on the low volume loop that you see there. but the majority of the research that we're doing under the Minroad research umbrella is on County State Aid Highway 8, County Road 8 up there, and then US 69. So we have installed the same preservation treatments up there, low traffic and high traffic, that we've installed down south, low traffic and high traffic. So if you drive about 45 minutes north of the Minroad facility that you saw in that last picture, into a little community called Pease, Minnesota, on US 169. That's where we installed our high traffic sections, and then kind of intersecting from that, we installed our low traffic sections on County State Aid Highway 8. These test sections were picked by Minnesota DOT, and they did a great job. Not just because they intersect at that common location in Pease that was very supportive of our mobilization and placement efforts in the summer of 2016, but the county road has a traffic level that's comparable to our traffic level on Lee Road 159 down south, and then US 169 in Pease is a divided 4-lane, and it almost perfectly matches our traffic level out on US 280. So there's a great similarity between the northern and the southern test sections. The big difference is down south we can get up to 105 degrees down here in the middle of summer, and in the wintertime they can see temperatures that are below 30 degrees, minus 30 degrees Fahrenheit up in Minnesota. So our expectation is high temperature performance pressures down south, and then low temperature performance pressures driving performance up north. The interesting thing is that our interim findings are very similar for both facilities. As an example, here's a shot of a single layer microsurface without on the left and with crack sealing as a pretreatment on the right. And we found that crack sealing it enhances the performance of overlying treatments when you're using it in combination with other treatments. And we found on the test track that it improves performance compared to untreated test sections. So when we're using it in combination with other treatments, it appears that blowing and banding is the best approach. And then when you're using it as a standalone, routing and filling looks like the best approach. But in both cases, we've seen a positive impact on performance, and that's true in the low traffic and high traffic down south, and then low traffic and high traffic up north. We've seen good performance in all 4 test locations. But up north, every single treatment and treatment combination that we've installed, low traffic and high traffic, has some amount of reflected thermal cracking. There was very aggressive thermal cracking on the low traffic road and the high traffic road. Some of that has reflected, but what we're seeing is different levels of severity in the reflection. And this is actually one of the thin lays that we placed up there, and it is a reflected crack in the thin lay. But we've seen trends in the treatments and the treatment combinations that appear to be very similar to the trends that we've seen down south. And we're using the same pavement distress equipment, the distress data collection equipment up north that we're using down south. All the data is going into a common database, and we're relating everything back to pre-treatment condition. So to finish this up very quickly and to summarize my comments in this presentation, we've seen the value of good materials, good designs, good construction, and good inspection at all 4 locations. We were very blessed to have the same placement contractors for the emulsions and the same placement contractors for the thin lays down south as we had up north. We had excellent regionally appropriate materials and excellent mix design. So we had a great team to build all 4 of our test locations, the 2 down south and the 2 up north, and it really shows through the good performance that we've noted with all the treatments and all the treatment combinations. We are documenting over time and traffic the life extending and the condition improving benefits of preservation. Life extending being the x-axis shift, and then the condition improving being the y-axis shift. We have observed and have documented a reduction in subgrade moisture contents for the treatments that we installed on Lee Road 159. That's a diminishing effect when the cracking comes back. We see subgrade moisture contents go back up, but I think it's the only experiment of its kind where we've been able to document that effect. As I said, we've seen similar trends in south versus north and low traffic versus high traffic. And we'll be very excited to report those findings in the coming years and continue to report those findings to the pavement preservation community. We've documented the benefit of crack sealing as a standalone treatment and as a combination treatment. We currently have 20 state DOTs that are supporting the pool fund for the NCAP pavement test track and the partnership with the Minnesota Road Research Project. We think we're going to have one more state joining within the next week or two, and we have proposals out to several other states. So we're approaching half of the states in the United States for participation, and we're very proud of that. And we anticipate extending the pool fund probably in 3-year cycles, long into the future, because some of the more robust treatments, it's going to take a long time for us to fully document the life extending and the condition improving benefits. Well, I appreciate the opportunity to make this presentation to you today. Again, I regret that I cannot be there in person, and we don't have the opportunity for me to answer questions online because my conference is starting right about now here in Auburn, Alabama. But my contact information there is on this slide, and I'll be very happy to follow up with you in any way that I can. But thanks again for the opportunity. Hello from Alabama, and have a great conference. Thank you very much.